Alright, and before we start this, there's just one problem I want to go over from the drill last time, and you might not have had this for your second problem. There's one that had cube roots, but it's the exact same thing. People were making this way, way, way too hard. The directions say to divide and simplify, and some people tried simplifying first, or they just, I don't even know on some of them. First direction says to divide. We can divide square roots, we can divide their radicands. So we just take 54x squared divided by 6x. It's still under a square root. So we have the square root of, oh, sorry, this was x cubed. Then we have the square root of 9x squared. So that's the divide part. You literally just have to divide the radicands, which is what a lot of people forgot. And this problem shouldn't have taken too much time if you followed those directions. Divided first, simplified second. And then the square root of 9x squared, that's actually back from 10.1. Everything there is perfect. Square root of 9 is 3. The square root of x squared is x. So if on your drill you had the problem that had the cube roots, you would do the same thing. You just divide the radicands. It ended up being a perfect cube. Simplify it. So don't make these problems harder than they have to be. Divide, simplify. Just what the directions say. Divide it first, divide your radicands, and then simplify them. So we can always divide radicands. We can also always multiply them as long as we have the same index, as long as we have the same type of root. So in 10.5, the first thing we're going to do is some multiplying. Directions, again, very, very important in this section, particularly because some of the problems look identical but are asking you for something totally different, which is going to be the second part of 10.5. Multiply as indicated. If possible, simplify any radical expressions that appear in the product. So we're going to multiply, and then if we can, we're going to simplify our answer. So here we have the cube root of 2 times 3 minus the cube root of 16. What type of multiplication are we going to need to use on this problem, do you think? How are we going to... If you saw something with a monomial out front and a binomial in parentheses, what would you do? Distribute. So it's the same thing. We're just going to be distributing a cube root. So I like to write out on these problems what I'm doing for the distributing before I actually multiply, because the big question is really, can I multiply those two things together? So it's going to be the cube root of 2 times 3. And then the cube root of 2 times negative cube root of 16. So what's the sign going to be? If I have a positive, I multiply it by a negative. Negative. So negative, and then I have the cube root of 2 times the cube root of 16. So that's the distributive property, the definition of it. Now the question for you is, what can actually get multiplied together? So if I have the cube root of 2 times 3, am I going to be putting that together at all? Like the 2 and the 3. Would I get a 6 out of that anyhow? No. One of them's got a cube root and one of them doesn't. You can't mix those. Those are oil and water. So we usually put the number first so it's clear it's not part of the cube root. But this is just 3 times the cube root of 2. Those two don't go together. Now, what if both of my numbers have a cube root with them? Can I multiply those together? Yes. So they both have to have that radical around them in order to multiply, or have no radical around them to multiply, but you can't mix the two. So what do I get when I multiply the cube root of 2 times the cube root of 16? Cube root of 32. So if you said 32, you might have written the cube root on your paper. I don't know that. I can't see that. But it's 32 for the numbers. You got to keep whatever their radical was around them. So that's the multiply part. The second part says to simplify any radicals if possible. So let's get these up here. So look at your list of perfect cubes. And see if either of those can be simplified. Which one? The cube root of 32. So which of my perfect cubes divides into 32 evenly? 8. So the second one I can simplify. It's got a product where half of it's one of my perfects. So I'm going to break that cube root of 32 up into the cube root of 8 times 4. And then what gets out front? 2. 2 comes from the cube root of 8. So we get 2 out front, and left over is the cube root of 4. Oh, I didn't line this up very well. Now the last question is always, can I go any further? So I have 3 cube root of 2 minus 2 cube root of 4. Now we're subtracting. Do those two go together? If you say yes, what am I combining? And then what's on the end of it? So we're subtracting. So I have 3 cube root of 2 minus 2 cube root of 4. Are those like terms? You got to think about what makes them like for adding and subtracting. Yeah, the radicands. If these don't match, they're not like. So this is, remember I said that when we did the rules individually, it's like, okay, I see that, I see that, I see that. But then we got to start distinguishing them in one problem. So multiplying, you can multiply any radicands together. The only time you can add or subtract is if you have like terms. And to be like, these have to match. Those don't match, so we're done. Add them. Including the index. Yes, if I had a square root of 2 and a cube root of 2, I could not put them together. Correct. Same index, same radicand. Great question. So that's going to have to be my final answer, because they're not like terms. I can't put them together.
And that's for
Multiplying, anything works. So it's like fractions. So when you add and subtract fractions, what has to be the same? Denominator. So they have to have that in common. When you multiply fractions, you multiply any fractions together. So it's the same thing with radicals. I can multiply, as long as they're the same index. I can multiply any radicals together, same index. But to add and subtract, I've got to have that thing in common. I've got to have that radical in common. Very similar to a fraction. Any other questions? Yeah. Yes. 3 cube root of 2 minus 2 cube root of 4. Yes, you likely will not get one number for these answers. So B, I have a binomial times a binomial. What's that process going to be here? Foiling. We're going to have to foil this one. So we're going to have to go first, outer, inner, last. So my first is really nice, actually. 7 times 3. I can do that. The outer is going to be 7 times negative 3 square root of 7. So I always like to think ahead, what's going to be my sign? Is it going to be a plus or a minus? So the first 7's positive, negative 3 square root of 7. It's going to be positive or negative? Negative. You have one of each. So minus, and then it's 7 times 3 square root of 7. And then my inner is negative 2 square root of 7 times 3. Positive or negative? Negative. I have one of each. So 2 square root of 7 times 3. And then my last is negative 2 square root of 7 times negative 3 square root of 7. Positive or negative? Positive. So the last term is a negative times a negative. It's going to be positive. I don't ever leave enough room. Move this over a little bit, see if I can fit it. So plus 2 square root of 7 times 3 square root of 7. Now you can try to keep the signs, positives and negatives, like with each term, but if you did, I would use parentheses. And I find if you use parentheses, sometimes people get confused on what you can and can't multiply. So easier, I think, if you place your signs as you go. You don't have to. Just make sure in each term you are multiplying. So we got 4 things we've got to multiply together. So 7 times 3 21. We got that. Now my next term is minus 7 times 3 square root of 7. What gets multiplied together in this term? What do you think gets multiplied together in this second term here? The 7 and the 3. So they don't have a square root, so they can get multiplied together. If they don't have a square root, we can multiply them together. So I have minus 21 square root of 7. And then my next term, I have minus 2 square root of 7 times 3. What parts of this term can get multiplied together? The 2 and the 3. So the numbers, again, that don't have the square root with them. So minus 6 square root of 7. And then my last term is 2 square root of 7 times 3 square root of 7. What do you think can I multiply in that last term? The 2 and the 3. So the numbers that don't have a square root. So 2 times 3 is 6. How about the square root of 7 times the square root of 7? It's not the same. It's going to be a square root, but what do you have to do with radicands when you multiply? So like, what did we do when we had the cube root of 2 times the cube root of 16? We multiplied them. We got the cube root of 32. So this is the one that people miss because it's the same number, but when you're multiplying, you've got to multiply your radicands. So square root of 7 times the square root of 7 is not the square root of 7. Square root of 49. You've got to multiply your radicands. And don't miss that just because they're the same. When you're multiplying, you always multiply the radicands, as long as you've got the same index. So now that we've got the multiply part done, we've got to work on simplifying, cleaning this up. So there's a couple of different things we can do to simplify it. So can anyone pick out one that they think we might do to simplify this? Okay, in the last term, what do we want to do? 6 times the square root of 49. What's that? Yeah, find the square root of 49. Sure, it's a perfect square. What's the square root of 49? 7. So here is a tip. Whenever you multiply a square root, it's only square roots. Whenever you multiply a square root by itself, you get just the radicand. So the square root of 7 times the square root of 7 gives us the square root of 49, which turns back to 7. If, and this is going to be important on the next part, let's say if you had the square root of 3 times the square root of 3. You're going to get the square root of 9, which is what? 3. If I have the square root of 5 times the square root of 5, I get the square root of what number? And what's the square root of 25? 5. It always happens with square roots. If you multiply it by itself, you get back that number. So you really could, if you were thinking ahead, if you remember this, skip this step right here and just said, okay, it's going to be 6, and then the square root of 7 times the square root of 7 is just 7. So this last term is 6 times 7, which is really 42. So I have 21 minus 21 square root of 7 minus 6 square root of 7 plus 42. And the last thing to check, can I combine any of these? Now we're back down to addition, subtraction. Are any of these like terms? So for adding, subtracting, you're looking for those like terms. Adam, what do you got? Negative 21 and negative 6. So these middle two terms are like. These are like because they have that square root of 7 on them. So I can combine the negative 21 minus 6 is negative 27. And what type of square root's on the end? Square root of what number? 7. Keep it. And you guys really got that one on your drill. I don't know if I saw anyone who didn't get that first question right. But what you have to remember is they have to be like terms to do that. Is there anything else I can combine? Dennis? Yeah. Negative 21 minus 6. The coefficients. You combine the coefficients. And then, Muna, what'd you say? 21 and 42. So 21, 42 is going to give me 63. Now, if you want to put plus 63 on the end, it's the same answer. I usually put the number first. Doesn't matter. Anna.
So when you're multiplying, anything goes.
Mm-hmm.
When you're adding and subtracting, you have to be like terms.
Yes. Multiplying anything and subtracting, make sure they're like. Yep.
Where did you get that? On the second step, you have negative square root. Oh, actually negative 7. 7 times 3, but then the next one is negative 7 times 3 square root of 7 right there. Where did you get that negative 7?
This one? So it's a positive times a negative. So the term's going to be negative. That's why there's a negative sign there. Again, you can put that in your work, but you'd really need parentheses if you wanted to do it like that, which is fine. So it was really, we were just determining the sign as we went, what that term sign would be. So last question. Can I put these two together? I have a yes, I have a no. Are they like terms? No. What do they both have to have on the end to be like terms? Square root of 7. So it's tempting. So you like to keep going on these, but that's the end. If one of them has a square root and one doesn't, they're automatically not like terms, unless something's not simplified all the way. So for C, what do you think we're going to have to do to start this out? What did you say, Devin? Write both of them out so you can FOIL it. So what you don't want to do in this problem is distribute the squared, which we did last time in 10.2, but the only time you can distribute the exponent is if there's no addition or subtraction in your parentheses. This actually goes back to our second day of class where we had a binomial squared, which said, okay, I'm going to have to write this twice. That's what my squared means, and FOIL it. So let's go through our FOIL. So our first is the square root of 3 times the square root of 3. There's two different things you could write here, depending on how simplified you want to get it to the beginning. Square root of 3 times the square root of 3 is the square root of what number? 9. You've got to multiply those radicands even if they are the same. So my outer is the square root of 3 times negative 7 minus 7 square root of 3. So positive times a negative is negative. And I would put the 7 first. If you have just one number, usually put it as a coefficient. And then the middle is negative 7 times the square root of 3. Another negative 7 square root of 3. And then last I have negative 7 times negative 7, positive 49. All right, now let's talk simplifying. So we got the multiply done. Now we've got to look at simplifying. Who's got a good starting step?
Square root of 9.
Square root of 9? What can we turn the square root of 9 into? 3. And again, you could do that as a first step as well. So that's going to be a 3. We're going to use perfect square. That works out nice. So I have 3. And you don't necessarily have to write everything down every step. If I can follow your work, that's okay. Can I combine any of these together? The negative 7 and the negative 7 is going to give me what? Yeah. Yeah, once it's all in line, we're combining like terms. So I get negative 14 square root of 3. So these two guys are like again. So I get the square root of 3, square root of 3. So negative 14 square root of 3. Anything else I can combine? 49 and 3. It's 50. Can I put those two together? No. If one's got a square root and one doesn't, and that square root's completely simplified, we're done. So I want you to try D. Try the big one. Write each thing you're multiplying together out, and then multiply the numbers in front, multiply the radicals. See how you can simplify. Okay, so let's put this one up. I don't know that we'll get to finish these notes today. I don't think so. Here. All right, so foiling. One thing to keep in mind is that each of these is a single term. Even though it's got two parts to it, they're each only one. There's 4 terms there. So when we go for our first, it's that whole 3 square root of 5 times 4 square root of 5. Then our outer, positive and positive, is going to be positive 3 square root of 5 times 5 square root of 3. Our inner, negative times a positive, is negative 2 square root of 3 times 4 square root of 5. And our last, again, is negative times positive, negative 2 square root of 3 times 5 square root of 3. So the parts I can multiply within a single term here. So this is one term. It's being multiplied. Multiply the numbers. Multiply the square roots. Even if the numbers are the same, multiply those together. For the next term, multiply the front numbers. 15, multiply the radicals, square root of 15. Multiply anything. As long as the radical is the same, you can multiply anything. The only time we're really picky is adding and subtracting. So the next term, negative 2 times 4 is negative 8. Square root of 3 times square root of 5, square root of 15. And then the last term, negative 2 times 5 is negative 10. Square root of 3 times the square root of 3 is the square root of 9. Multiply those radicands, even if they're the same. So now we've got to simplify. So a lot of you said, well, okay, I have square root of 25. I know that's one of my perfect squares. But then from there, I saw a lot of square roots of 5. If you're just going to talk to me and I ask you, what's the square root of 25? What do you tell me? 5. So don't put it under a square root. Saw several people do that. So this is just 12 times 5. So this first term is 60. Same thing for the last one. Negative 10 times the square root of 9. What's the square root of 9? 3. So this is negative 10 times 3, which is negative 30. And then I have 15 square root of 15 minus 8 square root of 15. So now we're down to adding and subtracting, so we're much pickier to what we can combine. So what can we combine here? 60 and 30. 60 minus 30 is 30. And then I heard the other. The 15 minus 8. So these two are like. Remember, when you get down to that adding and subtracting, we're focused on, do we have like terms? These are like, so you only combine the front numbers. 15 minus 8 is 7, and you keep whatever made them like. So we don't have time to rationalize today. I'm going to adjust the homework.